So let's go to number 1. Remember, if you have a copy of this yourself, make sure to attempt the problems and corrections on your own first for the best results. Come back to this for explanations as needed, because I post this on YouTube later. So let's do number 1. So it says we have the absolute value of 5x is going to be less than -5. Now, right away, I don't even have to do any algebra or solve anything, because I know absolute value means that I should have a positive answer. So it's impossible to get anything that's less than -5. So it's going to be no real solution. -3x plus 2 has to equal -10. Yeah, but the absolute value is going to equal 10. Of that is going to equal 10. So then you have -3x plus 2 is equal to 10. So then that means that -3x plus 2 can equal positive 10, or -3x plus 2 can equal -10. So then, let's see, we have -3x, we're going to subtract 2 from each side. So then x would equal -8/3, and then we're going to subtract 2 from each side here. Oh, I just must have done something stupid the first time. I don't know what I was thinking. My brain doesn't work sometimes. So then I'm going to subtract 2 from each side, get x by itself, and that equals 4. Wait. So that equals 4. What? What did I do? It's 4 and -8/3. Yeah, it is 4. But now I'm paranoid that I'm doing something wrong. I think I changed this problem and forgot to change the answer key, because the answer key is saying it's B for some reason. I don't know. That's tripping me up. Yeah, the answer key has to be wrong. So then let's keep going. So 6k plus 15 is equal to 0. K is the solution to the given equation. What is the value, what is the value of absolute value of k? Okay, so let's subtract 15 from each side to get k by itself, or 6k by itself. That's going to be -15, and then we're going to divide by 6 on each side, so we get -15 over 6. So k is equal to, that's going to be -5 over, because I'm dividing by 3 on top and bottom to simplify it. So it's going to be -5 over 2, -5/2. Now remember, we're finding absolute value of that, so I just have to turn it positive, and I just get 5/2. Or 2.5, same exact thing. Okay, so let's go, let me erase this so it doesn't get in the way. Over here. Okay, so what are some of the math concepts you have to know? So the most important math concepts, obviously you have to know basic algebra, solving for an unknown variable, because that applies to so many problems. You have to be really good at that, because even word problems, you have to set up equations and then solve for that, even if it's not that straightforward, asking you to solve for x. You need that that knowledge. So that systems of equations, you'll definitely be asked. They're really liking systems of inequalities lately too, and just regular inequalities, obviously. And then I would do just basic word problems, because there's a mix of different topics. Make sure you definitely know your basic stat stuff, mean, median, mode, that sort of thing, and linear equations. So if I had to boil it down to the stuff that I would focus on first, for most students, typically it would be some sort of mixture of that. But again, it depends on the student. Why did my mom share this with me? Okay, so let's go to number 4. A student is given a worksheet with a number line on it. X and Y are 2 different points on the number line pictured on the worksheet. Points X and Y are both 9 units away from where the number 3 is marked on the number line. Which of the following equations could the student use to find the coordinates of point X and point Y? So just think about this logically. So on a number line, you have the number 3, and then you're going to have X and Y being 2 different numbers that are 9 units away from 3. So if we go 9 in this direction, then we're going to get to the number 12, right? And if we go 9 in this direction, well, then where are we going to end up? We're going to end up at -6. So we have to think what fits this scenario logically. So you could just plug in values and see. So you could say, okay, -6 plus 3, that's going to be well, definitely not 9 when you do the absolute value, because negative 6 plus 3 is negative 3. Absolute value of negative 3 is not 9, it's positive 3. So it can't be that one. And then if I plug in negative 6 here, it's going to be negative 6 minus 3, which is negative 9. I take the absolute value of that, I get positive 9, but now let's check it for the 12. So then 12 minus 3 is also 9. Absolute value of 9 is also equal to 9, so that works, so it's B. Okay, so let's go to number 5 now. What is the solution to the given inequality? So I'm going to divide by 6 on each side. So then I'm going to get the absolute value of 4x is greater than negative 4, because negative 24 divided by 6 is negative 4. Now, remember, with absolute value, you have to think of multiple scenarios. So I have to think, okay, my 4x can be greater than negative 4, or my 4x could be less than, because I have to switch the, the inequality symbol when I divide by a negative or multiply by a negative, or basically like changing the sign is also how you can think about it, has to be less than positive 4. So now I'm going to divide by 4 on each side. So then I'm going to get that that's going to be negative 1, divide by 4 on each side, less than 1. And then let's see which of these, well, it's not going to be A, B, because they have the little line underneath. So it has to be either all real values or no real solution. So then this one's going to be all real values, because X fits the criteria for all of this, where like well, also you could have just seen that, yeah, like someone said originally, like the absolute value of 4x, like with the first one, but kind of like in the opposite manner, where like you could see the absolute value always has to be positive, so anything would work for being greater than a negative value. Or you could go through solving it and then also see this way, that like any number that we put for x, if it has to fit these two rules, it could be any number. Like x is greater than negative 1 and x is less than 1. That works for anything, basically. So all real values of x, C. Either way is fine. Yes. Sorry, I wasn't looking at the comments when you guys were saying that until the very end. But yeah, either way works. So then let's go to number 6. Which of the following equations matches the graph shown below? So, we have, someone said about, someone's saying something about limits, therefore I know the general idea I remember about limits, but honestly, I haven't done limits in a minute. I know it's like as x approaches a certain value, you're looking for like the function, what it goes towards, but I can't like off the top of my head think about how you guys are applying it to that problem. What did you get on the SAT? I didn't take the SAT, I took the ACT and I got a 34 when I took it. Okay, so let's see. Which of the following equations matches the graph shown below? So it looks like you guys are already... we were talking about other stuff. It's hard to keep up with the comments, guys. Sorry if I'm missing stuff. So let's see. You could just plug in a point, or you can remember your parent functions. Either one works. Most people are going to need to just like plug in a point, so I'm going to show that way. So this is going to be 2, 0. So your x is 2, your y is 0. So if you plug in 2 here for your x, you should get 0 for your y, which does not work there. It does work there. It does work there. It does work there. So then you would have to pick another point. Again, I know it's not the most efficient method. We would typically use the parent function, but most people don't have that memorized by test day. So I'm showing the other way. So then what I'm going to do is maybe I'll pick this point right here, 0, 2. So then 0, 2, that does not work. If I plug in a 0 right there, do I get a 2 for y? Because yes, the absolute value of negative 2 is going to be positive 2. And then if I plug in a 0 there, do I get a 2 there? No, because 0 minus 2 is negative 2. So that's how you could do it with just plugging in points if you don't have the parent function memorized. Are you guys fighting in the comments? I don't know. Okay, I'm just going to the next one. Okay, so let's go to number 7. Thanks for sharing the live, guys. So it says, Tom and Sylvia have built a pillow fort in their treehouse. They have a rule that only kids who are older than 1 year old and younger than 11 years old can enter their pillow fort, which of the inequalities represents this age limit. So they have to be older than, so like X would be like the solution that works. So they have to be older than 1 and they have to be less than 11. That's represented by the first one, where X would represent like the possible ages that fit that criteria. Now, if you start doing number 2, if you say, okay, X minus 6 has to be less than 5, or X minus 6 has to be greater than negative 5, because you have to flip the inequality symbol when you change the sign, you could solve for X there, and you could say, okay, I'm going to add 6 to each side, so then X is going to be less than 11, and then I'm going to add 6 to each side here, so then X has to be greater than 1, so X has to be greater than 1, or less than 11. That's the same thing as number 1, which works, so that one's right. And then you would say, okay, for number 3, whoopsies, it would be X minus 5 has to be less than 6, or X minus 5 has to be greater than negative 6. Again, I switched the signs, so I have to switch the inequality symbol. And then I have to just get X by itself, so this is going to say X has to be less than 11, which works for part of it, but let's check if the other part works. And then if I add 5 to each side, I get X is greater than negative 1. That's not true. Remember, it has to be that they're greater than positive 1. So that does not work. So it's just 1 and 2C. No, it's just 1 and 2. Not all of them, because of this situation right here. You can't just stop with like part of it works. You have to check that the whole thing works. Okay. So, is this 7th grade math? This spans several grade levels, the SATs. So this is like digital SAT prep. And this is the absolute value chapter. So, number 8, in order to not have a catastrophic lawsuit on their hands, a fireworks store has a very strict rule that each bin of fireworks must be kept at least 40 units away from the nearest customer. If a bin of fireworks is located at coordinate 20 on a number line, which of the following can provide the coordinates for the location of the closest customer? So, we're at the coordinate 20, so think logically through this. We're at the coordinate 20, they have to be at least 40 units away, so they could be at least 40 units, whoa, that was a terrible arrow, oh my god. At least 40 units this way, or at least 40 units this way. So they can be, if we go 40 units to the left, it's going to be at negative 20, so they can go to negative 20 or beyond, is what works. And then if they go 40 units this way, I think I said 20 by accident, I meant 40. If they go 40 units this way, so they're 40 units away from the 20 mark, they're going to be at 60. So it's going to be 60 or like farther works out. Like all of these values right here work, all of these values here work beyond the negative 20 and the 60. So we have to look for what represents that situation. So A says X is less than or equal to negative 20, that works. Or X is greater than or equal to 60, that works, so it would be A. The arrow reminds me of a firework. Point of view, I got a 790 on the math section. Good job. Okay, let's go to, let me get water again. Okay, so we're on number 9. So how many different integers could be the solution to the inequality right here? So be careful, don't just solve for what X is. It's how many different integers could be the solution is the question. So, X plus 8 is less than 5, or we could say X plus 8. I mean, you could kind of already see, but let's just, like, solve it. X plus 8 is less than 5, or X plus 8 has to be greater than negative 5. So then we're going to subtract 8 from each side, and it's going to be X is less than negative 3, and then this is going to be, if I subtract 8 from each side, that X has to be greater than negative 13. So it has to be between those values, like if we rewrite it so that it looks nicer visually. like this basically. So it could be negative 12. It could be, well, let me just write it out so people can see. Negative 12, negative 11, negative 10, negative 9, negative 8, negative 7, negative 6, negative 5, negative 4. Like all of those work because they're the values between negative 13 and negative 3 that are integers. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 different ones that work. So that's the answer there. Any integers less than negative 3 and greater than negative 13? Yes. When f of x is equal to all of that, what is the value of absolute value of f of 1? So basically just find f of 1 and then take the absolute value of it. So I'm going to start by doing that, like finding what f of 1 is. So I'm going to replace every x with a 1. So that's going to be negative 3, the absolute value of negative 3 times 1, which is just 1 times 1 squared, which is just 1, so it's just negative 3. And then negative 2 times 1 is just negative 2, and then plus 2. So the absolute value of all of that. So that's going to be negative 5 plus 2, which is negative 3 in absolute value bars, which equals positive 3. I'd write out word explanation so I don't waste something, and then I'd say the answer. Yeah, you could do that as well if you want. Whatever works for you. What are the solutions for this right here? So I'm going to divide each side by 6 to get the absolute value bars by themselves first. Or actually you could just like plug in if you want to as well, but I mean, I'm just going to show it this way for people that want to see it fully like solved out. So then if I divide by 6 on each side, I'm going to get that that's equal to 4. So then I have two options. X minus 1 could equal positive 4, or x minus 1 could equal the negative 4, because if you take the absolute value of negative 4, it's positive 4. If you take the absolute value of 4, it's also positive 4. So you have two options. So then you're going to solve for what x is. So add 1 to each side, and we get x is equal to 5. Add 1 to each side, and I get x is equal to negative 3. So then that's going to be A. So negative 3 squared is 9 minus 2. You're talking about this one? So remember, if you replace it with a 1, it's 3 times x squared, so it's 1 squared. And then you multiply what you get for that times the negative 3. So it's 1 times negative 3, which is just negative 3. Okay, so let me just erase all of this. And then, but yes, you could also like plug in if you want what x is to see if it works. That's an option as well. So let's go to number 12. So we're going to divide by 3 on each side to get the absolute value bars by themselves. And then I'm going to say, okay, x plus 4, since it's an absolute value bars, there's two options. It could be less than 4, or I could say x plus 4 is going to be greater than negative 4, because remember when I change that sign, I have to flip the inequality symbol. So now I'm going to solve for x in each of these scenarios. I'm going to subtract 4 from each side. That's going to give me x is less than 0. I'm going to subtract 4 from each side here, and that's going to be x is greater than negative 8. So if I put these together into an inequality, I think inequality statement is how you say that, but vocabulary always gets me. So x has to be basically greater than negative 8 or less than 0 when you put that all together. So that would just be B. Okay, let me get rid of this mess right here so it doesn't get all confusing. Okay. SpongeBob, you crack me up. Okay, so then let's go to number 13. So we're going to add 4 to each side, and then, because we're trying to get the absolute value bars by themselves. Oops, I wrote that wrong. So I'm adding 4 to each side, so then I'm just left with 4 absolute value bars. X minus 4 is less than or equal to 4, right there. Now I'm going to divide by 4, because remember, I want the absolute value bars by themselves. So then if I divide by 4, I get this. And then I have to remember, okay, it's an absolute value bar, so there's two options. So I could have x minus 4 is less than or equal to 1. X minus 4 is greater than or equal to negative 1. Now I'm going to get x by itself by adding 4 to each side. So x is less than or equal to 5. And then if I add 4 to each side here, I'm going to have x is greater than or equal to positive 3. So let's see, if we put that together, it's going to be that x is greater than or equal to 3, and it's less than or equal to 5. So then that would just be D right there. It's not C. Let me just double check my answer. Yeah, it is D. I did the math right. I always have to check because you never know. I flip things in my head, but yes, it is D. That is correct. It's not negative 3 because you have to add 4 to each side. So negative 1 plus 4 is positive 3. And then if you add the 4 on each side here, it's going to be 5. Okay, so let's go to number 14. No worries, I do things wrong all the time on live, and I'm a math teacher, or math tutor. And I wrote this book, and I still do stuff wrong because I calculate and flip numbers in my head. So let's go to number 14. We have that 5x minus 2 is equal to 108. And then we could also have that 5x minus 2 is equal to negative 108. And then we're going to add 2 to each side. And that we're doing that because we want to eventually get x by itself. So I'm going to have that that's equal to 110. Now I'm going to divide by 5, and I have that's equal to, no, that's not 25. That's equal to 22. So x is equal to 22, and then we could do the same thing over here. We're solving for x, so add 2 to each side. So then that's equal to negative 106, and then we divide by 5, and we get x is equal to negative 106 over 5. And then they're loving to do this, by the way, on the exam now, like how they used to say x has to be greater than or 0 or something like that. It looks like from what the study guide, based off of the digital SAT study guide that was released, that they're changing it up to, instead of saying stuff like that, putting it into words. Like they want you to have the negative, the positive value of something or the negative value of something. So just watch out for that. I forgot to state that at the beginning of the problem. So we want to find the positive value of this. So whichever of these is going to give me a positive value for that is what I want. Well, I know if I multiply 2 by a negative value and then subtract 4, I'm going to get a negative answer. So that's out of the question. So let's do the 22. 2 times 22 is going to be 44 minus 4, and that's going to be positive 40.